Hi Beckman students, this is part 2 of the 1D homework review. So let's start with number 8. You run from your house to your friend's house that is 3 miles away in 30 minutes. You then immediately walk home taking 1 hour on your return trip. So let's start with part A. What was your total distance traveled? Well, you know that going from your house to your friend's house is 3 miles, and then back to your house is another 3 miles. So your total distance, or your total ground that you covered, will be 6 miles. How about total displacement? So displacement, you only care about initial and final positions. If you're going from your house to your friend's house and back to your house, does your initial and final position change? No, it doesn't. So there's no displacement in this case. It's 0 miles. All right, C, what was your average velocity on the way to your friend's house? Well, velocity, remember, is the change in displacement over the change in time. So, if you're going from your house to your friend's house, you know that your displacement in this case is 3 miles. And the total time it took for you was half an hour, so 0.5 hours. Okay? In this case, your velocity is 6 miles per hour, and you're moving to the east. So remember, with velocities, it's a vector. It must have both direction and magnitude. Part D, what was the average speed? So speed is a scalar. We only need the magnitude. So what was the average speed for the entire trip? Well, the entire trip, right, was 6 miles. So remember, speed equals distance over time. The entire trip was 6 miles, and we're dividing it by the total time. And your total time in this case was 1 hour plus half an hour. All right? So if you do 6 divided by 1.5, your total speed would be 4 miles per hour. In part E, what was your average velocity for the entire trip? So your average velocity for the entire trip would be V equals change in displacement over change in time. But we know that the displacement was 0 miles. Total time, well, the total time would just be 1.5 hours, just like we saw before. But since there's a 0 displacement and you're dividing 0 by 1.5, your velocity will also be 0 miles per hour. All right. Let's go ahead and move on to number 9. So number 9, a skydiver is jumping from a plane and he is releasing his parachute to slow down. The skydiver's velocity is directed toward the earth. What direction is its acceleration? So we know that the skydiver is going downward, right? So his velocity is negative. Now think about it this way. If his velocity was increasing, then his acceleration must also be negative to make it even faster, right? So if you're slowing down his movement, slowing down his velocity, the acceleration must be in the opposite direction. Acceleration must be positive. So remember, anytime something's slowing an object down, you know that the velocity and the acceleration must have opposite signs, regardless of what the initial velocity's direction is. Okay? Number 10. The ticker tapes below show the motion of an object moving from right to left. Describe the velocity and acceleration of the objects as positive, negative, or 0 for each ticker tape. Okay, so these objects are moving from right to left. So that's what the start is telling us here. So let's start with X. X, we see that the velocity must be negative because it's moving from right to left. The acceleration is 0 because if you see the dots are evenly spaced, you know that it's moving at a constant velocity. And if it's at a constant velocity, acceleration is 0. Let's go to the next one, Y. This one's also with a negative velocity because we're moving from right to left. And the acceleration in this case is positive. Okay? And the reason it's positive is because it's slowing that object down, right? These signs must be opposite because the object's slowing down. Last one is also a negative velocity. And because it's speeding up, the acceleration will be negative. They have to have the same sign when they're speeding an object up. It's getting faster and faster in the negative direction, so it has a negative acceleration. All right, number 11. Explain if situations below are examples of acceleration or not. So part A, a skateboarder increases speed going downhill. Well, there's an increase in the speed, so yes, that is an example of acceleration. Part B, a car travels at the same speed limit on the freeway. Well, if you're at speed limit, you're at a constant velocity, so there's no acceleration. C, a runner makes a left-hand turn at the corner. So if you're turning, you're changing your direction. So yes, that is acceleration. Part D, a motorcycle comes to a stop at a stoplight. No, if you're just stopped at a stoplight, you're not accelerating. All right, number 12. And for number 12, what I'm going to do, let's see if we can turn down that brightness. Bring it back. All right, perfect. So for number 12, what I'm going to do is I'll draw the ticker tapes, and then we'll describe what's going on in each segment of that ticker tape. So here's my paper where I'm going to draw the ticker tapes. All right, let's start with A. So bicyclist travels at a slow constant speed, negatively accelerates to rest, remained at rest for 30 seconds, and then rode away very slowly at a constant speed. So here is my makeshift ticker tape. So he's starting off by traveling at a slow constant speed. Okay, so we're going to do evenly spaced dots, and they're kind of close together because it's slow. And then that bicyclist is going to negatively accelerate to rest. So it's going to slow down to rest, so the dots are getting closer together. Okay. It's going to rest for 30 seconds, and then they ride away very slowly at a constant speed. So I'm going to make the dots even closer together and evenly spaced. Perfect, all the way to the end. All right, so let's describe what's going on in each of these segments. So the first part is a slow constant speed, okay, basically up to this point. So the velocity, because we're moving from left to right, is positive velocity. Okay, but if it's constant, then acceleration must be 0. When there's accelerating to rest, that we're still moving toward the right, so it's a positive velocity. But now we're slowing down, so we have a negative acceleration. After that stop, we also have a positive velocity because we're continuing to move to the right. And the acceleration is 0 again because we're at a constant speed. All right, so let's go on and move to part B. So in part B, I'll draw my ticker tape first. Maybe not as long as before. There we go. So in part B, seeing a stop sign in the distance, a driver presses the brake in her car, comes to a stop at the stop sign. When it is clear, she presses on the gas and accelerates to 25 miles per hour. All right, so the first thing that we see here is a deceleration or a negative acceleration. So let's go ahead and start fast, and then we're going to start to slow down. Okay, and there's a stop. And then what she does is she starts to accelerate to 25 miles per hour. So we'll start small distances between each dot, gradually getting bigger until it's 25 miles per hour, and we're going to stay constant. And I'll say that's where the constant started. So let's start with the first part over here. Seeing a stop sign in the distance, presses the brake in the car, comes to a stop. In this case, we have a positive velocity because we're still moving toward the right. In this case, the acceleration will be negative. because we're slowing down. Next, we have the acceleration, right? So we're starting slow, moving faster toward the right, so it's a positive velocity, and we have a positive acceleration. And then over here, we have that constant speed. Whether you include it or not is totally fine. But if you did include it, it'd be a positive velocity, and acceleration would be 0. Finally, part C. Go ahead and draw my ticker tape right here. Okay. So we're also moving in this direction. And for this one, what we see is there's a skateboarder traveling at 1.5 meters per second, and then accelerates while going downhill, reaching a maximum speed of 2.5 miles per hour. At the bottom of the hill, the skateboarder maintains his speed of 2.5. Oops. This one should be hardly meters per second. Apologize for that. Okay, 2.5 meters per second. So we see that in the beginning, there's a constant speed, okay, constant velocity of 1.5 meters per second. So let's just draw a couple of dots showing that constant velocity. Then he accelerates while going downhill. So we make the dots a little bit farther apart, and then reaches a maximum speed of 2.5 meters per second. So I'm going to say up to here is our first constant speed of 1.5 meters per second. Up to about here is our acceleration. And then over here is our 2.5 meters per second. So let's describe what's happening in each of these. In the first one, that 1.5 meters per second, there is a positive velocity. But it's constant, so the acceleration equals 0. When we're accelerating, we're still moving to the right, so it's a positive velocity. But the acceleration is also positive because we're speeding up. And then finally over here, we have a positive velocity because we are still moving to the right. And then we have acceleration equal to 0 because it's constant. All right, I hope this homework review helps you. Let us know in class if you still have any questions. And we will see you in class. Bye.